Alright, so chapter 7 about list, more about the list. So we pretty much at this point know what is list and what are the operations that you can put on the list, right? So we have circle linked list, and we mentioned that once. So it looks like this. You add the end, which is tail, it's going to point back to head, right? So in this case, you no longer need a pointer for the head. You only need a pointer for the tail. Why? Because when you do tail.getNext, you get head. Okay. So like this, I'm talking about originally we have list pointing to the first, which is list is like a head. Now we actually can move list to the end because list.getNext keep your head the first. In that case, we can save one pointer, right? And that make your program more efficient. Reduce the code, reduce your pointer, save the storage, and iterate better. Because when you're at the end, you can just go to the beginning very easy now. This C stands for circular reference and sorted list. So I just want to show you how to implement this. So this is talking about how to implement reset and get next. So the reset method becomes more complicated in this case because normally you reset, you just set it to head, right? The get next method becomes simpler. Because when you add the end, get next pretty much get the next one for you. So if list not equals to null, list.getLink equals to current position. Again, so list always pointing to the tail. When it's not equals to null, that means the list is not empty. And list.getNext always give you the head. When you reset, you move the head. Then current position equals to head. That's how we reset. Get next. So current position.getInfo, put in the next, because get next will return the values, right? Now current position.getLink, so that's how we move, equals to current position. And when we move, that's why current position.getInfo always get next for you, because we keep moving to next. Now how would you implement toString in this case? So we set the string list string going to return that list. Looking at if it is empty or not. Alright. Normally we have is empty method, we can use that too, which is checking list not equals to null. If it's not empty, then we're going to iterate through the list. So we set previous node equals to the list, and the list now is actually pointing to tail, right? Then we said we have to do previous node.getLink, then get to the head, and then get info. Right, then we start the head, and then keep doing that get link, moving your previous node, and loop until it's not equal to the list. Because when it's equal to the list, that means it's get to the tail, and return the list string. find like contains, right? So we pass in the target. Same thing, we have to iterate through list. So that's why we check if the list is not empty. Now we set the boolean if we found returns true, right? Oh, this one actually not returning. So we use that boolean to stop. Once you found, you can stop. So let's see. In this case, you see that if not found, we keep searching. Once found, then you no longer have to get into the loop. That's one way. Or you can just do break inside once you find. That's another way. But in the textbook, they use the boolean to check. Now, we want to do at least once. So what's the difference between do while and while? We know that do while is do at least once. You're going to check at least once. So it's going to start from the end again, because location equal to list is tail. Then we have to move location.getLink. Then start with beginning. And previous should be end, because this is circular linked list, right? And we start to get info from the beginning if it does match. If it does, then return found equals to true. Then it's done. Otherwise, could keep looping and iterate to the list to the end of the list. So let's look at the remove method. So in general case, we want to remove B. So location identify, this is B, right? And when we use remove, we're relying on previous because we need to set the pointer of previous, right, to location.getLink, which is the one next to location. Like previous.setLink. So again, if we remove something at the first, we gotta set previous.setLink to location.getLink. So again, this is missing .getLink as well as this one. Removing the only elements, so that means location, previous, and list, they are equals to the same. Then we can just set list equals to null. Another case, if you remove the last element. The last element, so we have location pointing to that. And how do you know that's the last? When list equals to location. Right? Location equals to list, that's the last. In that case, we need to do the same previous set link, right, to location.getLink. Previous set link to location.getLink. And we have to move our list to previous. List equals to previous. So does the order matter in this case? No. It can be this one first and that one later, because we didn't use the list. We have location. So this is how we implementing it. Before we remove, we have to check That'll be fine. Now, in this case, you may see that this method not returning because the way they design is they make the file as the public to the class. That's why it's not returning true or false. And this pretty much just, if you see the way they define, is protected, not public. So that means it's only allowed to use inside the class and its successors. So it's protected. So it seems like that's why they just make it as fine to use inside, not like contains that we search for something and return. This is just used inside. So if found, like after do search, since found is the public to the class, then it's access to values of found. So if found, then we have to start to remove. Now we know that there's about 4 scenarios. How we gonna put them all in the code, right, to remove? So first, we check if it's a single element. If it is, then list equals to no. And checking by list equals to list.getLink, like I said, that's another way to check. Besides, look at location equals to previous equals to list. You can also look at list.getLink equals to list. Then that's the only elements. Then list equals to no. Else, that means it's not a single element. If it's not a single element, we have to see that if it is the last node. How do you know that it's last node? Last node. First, last, right? Previous dot get link equals to list, or location equals to list, right? If it's last node. So, this case, the textbook use previous dot get link equals to list. So, if it's that case, then we have to do list equals to previous. And the reason we do that because we don't do previous set link first, because this is always shared. Like if you look back, they always have to do previous set link to location or get link, previous set link to location or get link, previous set link to location or get link. So that means we don't have to repeat writing that code over and over again. And we know list equals previous can be in any order, so that's why we put it first. And then it's going to do this line of code. And no matter what, it's going to do this line of code, even if it's in between. And then reduce the number of elements, right? If it's in between, it still do this line of code. If it is in the first, it still do this line of code. So in between and the first, pretty much the same code. So this remove is working. And when removed, then you return the status is found or not. Add. How do we implement the add? Same concept, right? Create a new node first. And if adding to an empty list, set the list variables to reference the new elements. And link the new elements to itself. Because this is circling list, right? You just say list equals new and then list dot set links to the list itself, which that means new node. List dot set link to new node. Because when it's at the second and third one, then we have to link it to new node if it is adding always to the head. Now, depending on what type of list now, logic is going to be different. Usually always adding to the head, that means what? This is stack, right? So logic is different depending on what type of list. Add, remove.